Good morning. Now we try to discuss about the address binding. So what is the need of the address binding? Already we discussed it. Whenever the processor want to fetch the data or fetch the instruction or store the data, it must know about the address. Then only it is possible to perform the access the data or the access the instructions or the store the data in the primary memory. So the address binding is required. So for example, whenever we write a program, automatically the program is whenever we need to convert into the high level programming language to the machine language, so they clearly specify that the machine language instructions clearly specify what is the location they need to fetch the data. For example, we are assuming that there is the branching statements are available. If the controller want to go from one location to the another location, if the particular condition is satisfied, which location the instruction need to be go, that is either it may be the 100th location or the 500th location instruction the control need to be go. So those are specified using the address binding only. Similarly, we need to store the data. What is the location we need to store the data? For example, we simply say that a is equal to 10, but actually a is a variable. That variable is also be some memory is allocated for the particular variable. In that location only we need to assign a value, or we assign the statement is the b is equal to a into 50. And in that statement execution, first the processor need to fetch the values available in the A register, A variable. We are assuming that A some memory is allocated, so it need to fetch the value from that particular memory location. Later it perform the multiplication, the result is able to store into the B. So to perform any operation, automatically there is a need of the address binding is required. So here we try to discuss about the programs on a disk ready to be brought into the memory to execute from an input queue. So already we know that actually the way the programs are existing, the programs are available in the secondary memory. Whenever the user want to run his program, it need to be brought from the secondary memory to the primary memory. Then only the process state is changed from new to the ready state. Initially, whenever the user want to run his program, initially it is in the new state. Once the operating system allocate the memory and the process is bring from the secondary memory to the primary memory, then only its state is changed from the new to the ready state. So automatically they simply explain that programs on a disk, it is actually available in the secondary memory and ready to be brought into the memory to execute from an input queue. And without support must be loaded into the address. We are assuming that the program is loaded into the beginning of the primary memory. But is it possible to load the beginning of the primary memory? It is not possible, because actually there is a total primary memory. Some portion is allocated to the operating system and the remaining portion is considered the user space. In that one also it is allocated for the different processes. So it is not possible to get every process is loaded into the address of the beginning 0000. It is not possible. Inconvenient to have first user process physical address always set the beginning of the primary memory. It is not possible to allocate for every process in the beginning of the primary memory. So how can it not to be? Why it is not possible to allocate? For example, we want to execute the 4 processes P1, P2, P3, P4, and the operating system is also needed into the primary memory. At maximum, either the operating system or if any one of the P1, P2, P3, P4 is loaded into the beginning zeros, the remaining must be loaded into some other memory locations. Further, address is represented in different ways at different stages of the programs of life. What is the programs of life? Whenever we need to type the program and save it, it is available in the secondary memory. And whenever we need to perform the compilation, automatically already we know that at the time of the compilation, there is a possibility of the source code is converted into the machine code. And again the linkers is required. What is the need of the linkers? If there is a possibility of the library functions are called in our program, we need to link all these library functions. So automatically linkers and loaders will be blind, relocatable address need to be generated. And once the relocatable address is generated, each binding maps one address space to the another address space. That is nothing but based on the execution. For example, initially the program is available in the high level programming language. Whenever the user want to compile, initially the program is each instruction is converted into the machine code, and once the machine code is that is the compiled code address bind to the relocatable addresses are existing. What is the meaning of the relocatable? It is possible to give the relocation is possible, and once we are using the linkers and loaders will be bind the relocatable addresses to the absolute address they are able to generate. And one more important, once the absolute address is generated, what is the meaning of the absolute address? Where the actual instruction or the data is available. But actually each binding maps to the address space to the another address, that is nothing but we know that what is the binding, where the primary memory is allocated to our process. So automatically it is also be changed. So automatically one time, first time we are executing the program, one memory location is allocated. After some time we want to execute the same program again some other memory is allocated, because it is not possible to allocate the same memory to the particular process. For effective utilization of the memory, different times of execution, different memory locations are allocated. And another one is for the addresses representation in different ways at different stages of the program lifecycle is they briefly explained. The first one is the source code addresses are usually the symbolic, that is nothing but they give the symbol. Example is, for example, in our microprocessor programming or the Pascal programming languages, we simply give the symbols label, that is some particular instruct go to X colon, and wherever the control goes to the particular location, there we give the X colon, that is nothing but the instruction locations are also be represented using the symbolic location. So generally in the high level programming languages, that is the source code addresses are usually the symbolic representation it is existing. But whenever we are using the compiling code addresses are bind to the relocatable addresses, that is nothing but they are given the relocatable addresses are given. It is possible to relocate from one location to the another location. And next one is the linkers and loaders will be bind relocatable addresses to the absolute address. That is, whenever we need to run our program, the linkers and loaders are used to load our program into the primary memory. At that time, they are given at the absolute addresses are given. And one more important one is each binding maps one address to space to the another one. That is based on the execution, its binding is also be places into the different locations. And next one is the address binding of instructions and data to memory addresses happen at the three different stages. One is the compile time, and another one is the load time, and another one is the execution time. So first we try to discuss about the compilation. If memory location known a priori, absolute code can be generated. Must recompile code if starting location changes. For that reason, at the time of the compilation, they are giving the relocatable address. So here they clearly explain that is at the time of compilation itself, we clearly know that what is the memory location the program is resided in the primary memory. Then automatically at the time of the compilation at time itself, it is possible to calculate the absolute address. But what is the limitation of that one? If you are calculated the absolute address, every time we run the program, the same memory must be allocated. If it is not possible to allocate the same memory, because the memory is allocated to some other process and we want to load our program in another location, in that case again we need to perform the recompilation. To overcome that limitation, generally the compilers are generated the relocatable addresses. That is, it is possible to relocate from one memory location to the another location. Generally most of the compilers are generating the relocatable address, and based on the operating system allocated memory, it is possible to calculate the physical address, absolute address is calculated. And another one is the load time. That is nothing but what is the meaning of the load time? What is the difference between the compilation and loading? The compilation is used to convert the source code to the machine code. That is, we write a program in the C programming language that is available in the, it is saved in the .c. It is in the source code. And once we compile, it is generated the executable file. So that is nothing but the executable. So the compilation purpose is to generate the source code to the machine code. And what is the load time? Whenever we want to run the executable file, that is at that time only it simply loaded. That is, must generate the relocatable code if memory location is not known at a compilation. That is the compilation time. If the memory location is not known, they only generate the relocatable address. From that relocatable address to the absolute address is calculated in the load time. And one more important one is the execution time. binding delayed until some cases at the time of the execution. For example, we are assuming that in the demand paging technique, so a program is consisting of the 1000 pages. All the 1000 pages are not loaded into the primary memory in the beginning. Based on the requirement, it simply loaded a particular page based on the requirement. So automatically at the time of execution time, they are able to calculate the physical address is calculated. That is nothing but the execution binding delayed until runtime. If the process can be moved during its execution from one memory segment to the another, need hardware support for the address mappings is required. We will discuss in detail in the demand paging technique how the physical address is calculated based on the logical address. So I hope you are able to understand the binding is done in 3 times. One is the compilation time, and another one is the load time, and another one is the execution time. Nowadays most of the programs are supporting the execution time, because nowadays most of the operating systems we are using the demand paging technique for effective memory utilization. But in the olden days, for example, we know that we are only running only one program in our system, and we clearly know that we are running one program, and where the memory is allocated we know. So automatically at the time of the compilation time itself, we are clearly specifying the instructions of the particular data is stored in this location, the program need to be stored into the particular location. So the compilation time itself we are able to calculate the absolute address. What is the advantage of that one? No need to recalculate different times. But what is the limitation? Every time we need to run the program in the same memory location need to be allocated. It is not possible to allocate some other memory location. If you want to allocate some other memory location, we need to recompile the program. That is the limitation. And what is another one? Load time. What is the meaning of the load time? Whenever we want to run our program, already the program is compiled and the machine code is available, and whenever we need to load, then the entire program is loaded from the memory to the primary memory, then the load time at the absolute address is possible to calculate. But nowadays most of the systems are supporting the demand paging. Based on the requirement only, the particular pages are loaded from secondary memory to the primary memory, need not move the entire program at a time into the primary memory. In that case, the binding is done at the time of the execution time. So these are the 3 types of binding. One is the compile time, and another one is the load time, and another one is the execution time. And which one is the most efficient one is the, if you want to effectively utilize the memory, execution time binding is the advantage. But what is the limitation? Every time it need to calculate. So automatically at the time of the execution time, from the logical address to the physical address need to be calculated, and based on the physical address it is able to perform the operations of the fetch the data, the instructions, or the store the data into the memory is possible to done. So these are the binding of instructions and data to memory. These are the 3 approaches. So here we try to discuss about the multi-step processing of a user program. Already we know that we have the source program. What is the meaning of the source program? Whatever the instructions we have written in the high level programming language, either it may be the C, or it may be the Java, or it may be the any programming language we are using. We want to perform a particular operation. What is the program we have written? That is considered as the source program. And next one is already we know that compiler. What is the need of the compiler? It simply converts from high level programming language into the machine level language programming language. And nowadays we are using the C compiler and Java compiler we are using to convert. And in the olden days we are using the assemblers. And what is an assembler? Is one of the program. It takes the assembly language program as an input and converts its equivalent to machine code is generated by the assembler. So in the olden days we are widely used the assembler, but nowadays we are using the compilers are used to convert the source code to the machine code, and assemblers are used to convert the assembly language instructions to the machine code. And assembly language instructions are just like the English commands. Example is the add a comma b, or the sub or mul. These are the commands are used in the assembly language program. And next one is the object model. Once the compiler is compiled, automatically the machine code is generated. It is called as the object module. And next one is the linkage editor. What is the need of the linkage editor? For example, in our program we use the scanf function or the printf function or some other library functions are called. Those need to be linked, then only it is possible to execute, because whenever we are using the scanf, again internally it is having a set of instructions to perform the scanf operation based on the parameters we are passing. Automatically that one is done by the linkage editor. It simply link out of the predefined functions we called in our program. And once it is compiled, linkage editor process is also be completed. We are able to get the entire executable code is available. Now the load module, it simply used to load our executable file from the secondary memory to the load module is available, and the loader is used to load that particular module into the primary memory. In memory, binary memory is existing. So automatically some cases, for example, some cases we are able to load the entire program, and another possibility is we are using the dynamically load the system libraries. System libraries are dynamically loaded and to perform the execution operation. This is the multi-step processing of a user program. That is nothing but once the user writes his program in the high-level programming language, first task is simply compile the program, then it simply generates the executable, the object model is generated. Next we are using the linkage editor is used to link all the predefined library functions, then load module is available, then the loader is used to load that entire executable file into the primary memory. So I hope you are able to understand about the multi-step processing of a user program. We will discuss the remaining in the next class. Thank you.